No, I'm not going to proceed to construct the values here, but I am going to make sketches that sort of represent the construction. So let's take this point here. Okay, value of the cosine is this big. That's a bigger proportion of the unit length than before, so that when I draw the value of the cosine, it's going to be about this long. Okay, so let's just do this. That looks about right. Oops. Now these lines are going to cross, or curves, I guess. Okay, so there's the value of the cosine at this point, and that's a little bigger than the value of the cosine was at this point. And now I construct my unit length, which is this. Okay, that's going to bring me down to about here. And I'm going to get a triangle that looks something like this. Not as steep as this one, although I'm not sure I drew it all that accurately. So here's I've got my 1, here I've got my cosine. And now I sketch my segment of length 1. So now I've got a segment of length 1, but 1 is only a little bigger now than the cosine, so that when I construct the side that gives me reciprocal cosine, it's going to be somewhat shorter than the one I had previously. Now I'm going to construct a triangle analogous to this one. So here's my reciprocal cosine. I don't think it's quite long enough. Okay, so it has come out a little further. And here is my length 1. And now I want to construct my value of the sine. Well, the sine is much shorter. It's only this big. So if I construct that value, here's my value of the sine. And I'm not going to try to label that, but we know that's the value of the sine. And now I can complete the construction. And we see that here is my value of sine over cosine. Okay, quite a bit shorter than before. So that value would go here, maybe about here. Now, if we go to this point, things are going to change quite a bit. Okay, the value of the cosine now is going to be kind of small. So let's sketch that here. So there's, say, our value of the cosine. Here's our value of 1. Cosine's maybe a little bigger than that. Here's our hypotenuse, which we extend. Then we sketch our segment of length 1. Is that long enough? That's way too short. Still probably too short, but we get the idea. Okay, so now the reciprocal of the cosine is significantly bigger than before. So let's draw an arrow indicating that this picture corresponds now to this point. Well, now I'm going to have to draw pretty long segment indicating the reciprocal of the cosine. And here's my segment. Of length 1. Complete this triangle. And construct my value of the sine, which is somewhat bigger. Okay, so here's the sine. And now I complete the triangle running parallel. And I get my value of the tangent. So here's my tangent. Here's my tangent. Okay, now this tangent is quite a bit bigger than the others. It's up here someplace. Now let's think, I don't want to try to draw any more of these, but let's think of what happens if this point here is very close to this point. Okay, so we choose a position on our horizontal axis corresponds to where the cosine becomes 0, close to the point where the cosine becomes 0. What's that going to do to our picture? Well, it's going to make our cosine much shorter than it is already. The cosine might only be this long. Okay, very short cosine. And then we draw this side. Well, this side is going to be the same. This side is going to get shorter. So this line is going to get, the hypotenuse is going to get much steeper. So that when we go over 1 unit here, we've got to go way down to get the value of the cosine. So the value of the cosine will be, probably, a couple feet, several feet long. And if it's not long enough, we can just come in closer to this point, making this side even shorter. So we get these extremely steep segments representing the hypotenuse. Again, every time we got to go over 1 unit here in order for the proportionalities to work out, so that this side of the triangle gets longer and longer and longer. Since there's no limit to how short this side can get, there's no limit to how steep the segment representing the hypotenuse can get, so there's no limit to how far we might have to go down in order to complete a triangle with hypotenuse 1. Meaning that the graph, and I just lost my red chalk. Come on. Yeah, there's a nub. Okay, meaning that as we approach this point, or approach this vertical line, these values just take off like crazy. So the graph of the tangent function is going to look very much like this. Now, there's a symmetry involved here. We're going to get the same values kind of moving backward, but since the cosine is negative and the sine is positive, then between here and here, our graph is going to look something like this. And then between here and here, where the cosine again becomes 0, so that everything that I just said happens again. Well, now both the sine and the cosine are negative, so when I do sine over cosine, I get a positive. So the graph is going to look like this. And then you can verify by symmetry and so forth that the graph is going to do this. And it's just going to keep doing this. It's going to repeat this. Okay? In other words, this would continue and go back up to an asymptote. So it would be this, and then a repetition, a repetition, a repetition, forever. You also see that the tangent function begins repeating at the point that corresponds to only half a cycle around the reference circle. So the tangent function will repeat, because everything from here to here repeats from here to here. It keeps repeating. Will repeat with half the period, half the cycle length of a sine or a cosine function.